Hello, today we're going to cover how to do 1D FEA. It's going to be great. Here's a little sample part that I've thrown together quickly in SolidWorks. You guys pretty much already know how to do this. This is just a sketch. Notice it's all made up of just sketches, so that way we can do 1D analysis on it. First thing I'm going to do, I'm not even really going to bother saving it as a part. I'm going to head and go straight to Save As. I'm going to save it as a IGES file. And I'm just going to save it to my downloads folder because that's really easy, and I'll call it part 1. Make sure you hit options and make sure export sketch entities is selected and checked. Then hit OK and hit save. Now that I've saved this part, I'm going to go into NX. I'm going to open a new file. And sure, I'll call it model 2, and it'll be put in that same folder, the downloads folder. Make sure you don't allow it to save in its default UGII location. That gives problems for our computers for some reason, but hit OK. Next thing we gotta do is go ahead and import that part we just created. Remember, it's not a parasolid. We saved it as an IGES. So hit IGES and then select it, part 1, and hit OK. It'll think for a minute about how exactly it wants to import this file. Then it'll tell us all about what it does. There we go. Look at all of that great information we just got. I'm sure that means something to somebody much smarter than me. But all I really care about is what's coming next. There we go. There it is. Great. So the first thing I'm going to do is notice I need to start my advanced simulation. And then, just like last time, create a new FEM and Sim. Very important to hit geometry options and select all on. OK. OK. And I'd name it something better like 5G crush load or something like that, and then hit OK. And we're already in our FEM, so that's pretty fantastic. I'm going to select, instead of 3D tetrahedral mesh, I'm going to select a 1D mesh. Go ahead and select everything. I am going to keep it as a C-beam. I think the automatic number for that is 1. First thing I want to do is check auto chain selection because that's important. I think the auto number of elements is 1. Don't use that, especially because we have some curved elements here. If that's represented by just one element, it's going to just be a line. We don't want that. That's not too realistic. So just use your engineering intuition to figure out how many elements-ish we want along here. I'm going to go ahead and save this part. We'll do 10 elements. Why not? We are going to merge duplicate nodes. And instead of automatically creating a destination collector, I'm going to create a new one, customize it a little bit. Beam property, instead of doing none, I'm going to create my own physical one. The for section I have to define myself. So I hit show section manager, and then create section when it pops up. Hello, where did you go? Little window? Well, oh, okay, cool. Well, I'll try that again. Same thing as last time, auto chain selection, C-beam, 10, mesh, create new, click. Okay, that's weird. Well, maybe I'll edit that out or something. I don't know. Maybe I'll be too lazy. Instead of rod, we use tubes, right? We use steel tubes. For this, I think I made it like this side length is 50. I can't remember what size tubes we use. I think like 25.4 millimeters in the outer diameter. I don't know, we'll say 20 millimeters for inner diameter. Whatever size tube you guys are using, make sure to input the inner and outer diameters correctly with the correct units. Hit OK. Hit close because we created our cross section. And notice that the for section is now 2, which we just created. Material, instead of inherited, I want to change that. We use 4140 steel. I don't think I have that material in this library, so I'm just going to hit steel. And there's no non-structural mass, so I'm just going to hit OK. And hit OK again. And hit OK at third. That looks good. All right, And so this is what your closing mesh should look kind of like. Um, that looks about right. A lot of elements. Each of these is made up of a bar. Pretty obvious. We just created our mesh. Now we're gonna move on to our sim. I'm gonna double click on sim, just like in the 3D FEA. First thing I'm gonna do is I'm gonna apply a constraint of some sort. We used fixed constraints, and this is going to be applied wherever it's fixed to the car. So I'm going to go ahead and say it's fixed to the car right there, and right there. I've made sure I got my node selector on, and I've just selected 3 nodes that are connected to the car, and I hit OK. The loading is going to be a little bit different. I'm going to apply a load right there. Again, I'm making sure to select a node. I'll apply a load to that node right there. And I'll say this is 100 newtons, but you guys know that the regs say that we have to apply 5 times the weight of the car, 5 G's to the crush zone. So that's what you'll be inputting. And then specify a vector. I'll say I want it along the z-axis. It's pulling in like that. Make sure, I mean, that's pretty obvious. Yeah, you guys are smart. Hit OK. So now I've got a force. I've got some constraints. I'm ready to solve. Hit solve. Hit OK. It does all the hard work. Remember, if you want to look really cool while it's throwing some crazy text up, just make sure you're pretending to type really fast. Then you hit close when it says job finished, cancel, close, go to results, double click on the solution, open it up, and we don't care about elemental stress. What we do care about is element nodal stress. There we go. That looks perfect. Note, this value, 3.655, is the number that we care about. Why, you ask? Well, because, remember, I said that I wanted steel. So what I'm going to do is remember that number, 3.655 megapascals. I'm going to go to a table on Wikipedia. I'm going to say wikipedia.org, ultimate tensile strength. There we go. I'm going to look at this and I'm going to say, well, the ultimate tensile strength of steel, 130 steel, is 1,110 megapascals. Well, 3.655 megapascals is a lot less than that. So we should be good to go. Realistically, you guys apply a safety factor to that, 1.4, and we'd be seeing a lot higher loads. So, this is just some numbers I threw together. Obviously kind of small. If I wanted to, a more realistic model might get us going a little bit higher than that. But yeah, that's all you got to do. If let's say this number was way too high, what I would do is I'd look at this and I'd say, let's see, where am I failing? Well, I'm failing right there, that little red spot. So how can I strengthen that? And I go in and I look and I say, maybe I can put another bar right there. Maybe I can just thicken this bar. Maybe I can thicken this bar. Just basically find ways to spread that stress around in different ways. Your engineering intuition, use statics, draw a free body diagram, but that's really all you got to do. Thank you very much. Hope this was informative. Love you guys. Peace out.